Hello, myself Pradeep Kumar, a faculty member in the Department of Electronics and Communication Engineering, ATME College of Engineering, Mysuru. In this video, I'm trying to explain some basic concepts related to a course called Embedded Controller Lab. Basically, the embedded controller is a device that often used to do monitoring and controlling functions, such as gathering sensor readings and controlling the actuators like relays and motors. The important feature of embedded controller is external PC is not required to control the system operation. Though microprocessor and controllers can be used to design embedded controller, most of the time microcontrollers are preferred because microcontrollers consumes less power. So an embedded system is one that has computer hardware with a software embedded in it. So in this course we have to understand an architecture of the hardware and we have to develop a program so that that program can be embedded on that hardware. The hardware used in the laboratory is LPC 1768. It's from NXP company, that is founded by Philips, and you can develop a program either in assembly language or in embedded C language. So some features of NXP LPC 1768 are: it is a ARM 32-bit Cortex M3 microcontroller. The CPU clock is up to 100 MHz, which has 512 KB on-chip flash ROM, which supports in-system programming and in-application programming. It consists 64 kilobytes of RAM. It supports nested vectored interrupt controller. There are 8-channel general purpose DMA controller, and very importantly, it has advanced high performance bus matrix, and so on. As we know that embedded controller will accept the data from the sensors and it will control the actuators connected to it. That means it will take the information from outside world and it will send the information to the outside world. That information is in the form of digital data, and this digital data will be transformed from outside world to the controller and from controller to the outside world through a general purpose input output pins. So the registers, data structures which corresponds to this general purpose input output pins are defined in an header file lpc17xx.h. Therefore, when you develop a program for LPC1768 and if you want to use the general purpose input output pins to transfer the data, then this LPC17xx.h header file should be included. And this LPC17xx.h header file is based on CMSIS, that is Cortex Microcontroller System Interface Standard, and this standard is developed by ARM. The available general purpose input output pins is grouped into ports. Hence LPC1768 has 5 ports, that is port 0, 1, 2, 3 and 4. The associated register of each port are grouped into a structure with the naming convention LPC_GPIOX, where LPC refers low power controller, GPIO refers general purpose input output, and the X refers port number. That means X indicates 0, 1, 2, 3 and 4. Each port consists 32 pins. Okay. The important point to be remembered is, even though each port consists 32 pins, all 32 pins cannot be used for your application because some of the pins in each port are reserved. Those reserved pin cannot be used. So this is the naming convention for pins, that is px.y, where X is the port number. Since we have 5 ports, X varies from 0 to 4, and Y is the pin number. Since each port consists 32 pins, that Y can vary from 0 to 31. Example, P0.7 refers 7th pin of port 0, P2.11 refers 11th pin of port 2, etc. Let us consider the registers associated with general purpose input output in LPC 1768. So the registers on LPC 1768 are present on peripheral advanced high performance bus for fast read and write timing. So these are basically fast input output, and hence the naming convention in the datasheet uses a prefix of FIO. Here FIO refers fast input output for all the registers related to GPIO. So these are all the registers associated with LPC 1768 general purpose input output. So the registers are pin selection register. So this is used for selecting the pin function, direction register to configure the direction, and FIO set, FIO clear and FIO pin. These are all used to access the port pin. Let me describe each register briefly in the next slides. Let us consider pin selection register. The necessity of the pin selection register is since almost all the LPC 1768 pins are multiplexed. Multiplexed means each pin can perform more than one function. That is, each pin can perform minimum one function and maximum of 4 functions. So the multiplexing, pin multiplexing is a scheme adapted to reduce the number of pins in the controller. So therefore the required function can be selected by using pin selection register. So the pin selection register is used to select a function of a particular pin because each pin is multiplex. So there are 11 pin selection register to configure the port pin. Since each pin of the port can perform multiple function, here minimum one function and maximum 4 function. To decide the functionality of the each pin, the pin selection register, 2 bit positions of the pin selection registers are required. Therefore, every pin of the port is mapped to 2 bit positions of the pin selection register. For example, a 32 bit pin selection register, 0 register, can decide the functions of pin number 0 to 15 of port 0. That means port 0th pin is mapped to the first 2 bits, that is 0 and first bit of pin selection 0 register, so that 0 and first bit of pin selection 0 register will decide the functionality of the port 0. For example, look at here. So this is a pin selection 0 register. So this pin selection 0 register is used to decide the functionality of the pin 0 to 15 corresponds to port 0. So here the bit position 0 and 1 of pin selection register is mapped to port 0.0, that means 0th pin of port 0. So these 2 bit position will decide the functionality of the 0th pin of port 0. For example, if these 2 pins are 0, that means if these 2 bit positions are 0, 0, the 0th pin of port 0 will perform default function, that is general purpose input output. Suppose if it is 0, 1, then this 0th pin will perform second alternative function, and if it is 1, 0, it will perform third alternative function, and if it is 1, 1, it will perform fourth alternative function. By default it will perform GPIO if it is 0, 0, otherwise first, second and third alternative function will be chosen by putting a proper value. So in this case, for example, in this case the port 11th pin of port 0, 8th pin of port 0 and 0th pin of port 0 are configured as general purpose input output pin. That's why, and when you are going to configure a particular pin as a particular functionality, and you have to make the rest of the bit position as 1 in order to ensure that so the other pin functionality should not be altered, because some reserved pins have some specific function that should not be altered. Now to ensure that the rest of the bit position should be mapped with 1, padded with 1. Therefore the corresponding hexadecimal value is F3C, F. So this value should be logically ANDed with the earlier value of the pin selection 0 register. Therefore you are masking the functionality of the other pin. Therefore by ensuring you are not altering the functionality of the other pin, and you are trying to change the functionality of the pins which is subject of interest. Okay. Similarly, if you want to configure pin number from 16 to 31, then you have to use pin selection 1 register. Similarly, if it is port 1, then you have to go for pin selection 2 register, and as well as pin selection 3 register if it is port 1. Okay, fine. Similarly, for port 2 it becomes 4 and 5. That means pin selection 4 and pin selection 5 register should be used to configure the pins of port 2. This is about pin selection register. Okay, the pin selection 0 and 1 is used to configure the pins of port 0. Pin selection 2 and 3 is used to configure the pins of port 1, and 4 and 5 used to configure the pins of port 2. Likewise, the pin 8 and 9 is pin selection 8 and 9 is used to configure the port 4 pins, and pin selection 10 is dedicated for trace port enable. So this is about pin selection register. Register is FIO-DIR, that is fast input output direction control register. The direction refers your particular pin can be an input pin or output pin. If it is an input pin which is going to accept the data, read the data from the outside world, and if it is an output pin which sends the data to the outside world. Okay, so this direction register is used to indicate or used to configure the particular pin as either input pin or output pin. Okay, so if again this FIO-DIR is a 32-bit register, and each bit of that register is mapped to each pin of a port. That is, bit position 0 of the register is mapped to 0th pin of the port. Similarly, 31st position of the register is mapped to 31st pin of a port. Suppose if a particular position of the register is 0, that corresponding pin will be act as an input, and if the value of that particular bit position of the register is 1, then that pin will be act as output. Okay, let us try to understand the direction register. So FIO-DIR, it is a direction register, fast input output direction register, which is of 32-bit size. Okay, that is 0 to 31. So each pin of the port corresponds to the bit position. Suppose if you want to make the 0th pin of port 0 as an input port, then the corresponding bit position should be 0, and if you want to configure the 0th pin of port 0 as an output port, then this particular bit position should be 1. Okay, so in this example, port 0.0 is an output port. Similarly, the 15th pin of port 0 is also acting as an output. Similarly, 16th pin, 17th pin and 18th pin of port 0 is configured as output port. Okay, so and the corresponding hexadecimal value, because in the programming we will represent these register values in hexadecimal for easy of the programming. The corresponding hexadecimal value is 0x00078001. So if you force this value to the FIO-DIR register, so these pins, that is 0th pin and 16th, 15th, 16th, 17th and 18th pin will be acting as an output pins. Now let us go with the other register, that is FIO set registers, that is called fast port output set register. So this register will use to send a logic 1. When you want to send a logic 1 value to the outside world, then this register will be used. And make sure that if you are using FIO set, that particular port pin should be an output port pin. That means you are sending the data to the outside world. So if you are using FIO set register, that particular port pin should be configured as an output port. So if you want to send logic 1 via that output port, then a corresponding bit position of FIO set register should be 1, and if you put 0 in that particular bit position, it doesn't have any effect. Okay, I repeat, if you put 1 on a particular bit position, so through that pin you can send logic 1 value, and if you put 0, it doesn't have any effect. And again, FIO set register is 32-bit wide. So let us consider FIO set register, fast input output set register. This register is used to send logic 1, And suppose if I want to send logic 1 via port 0.3, okay, then the third position of the register should be 1. Again, it's very important that the 0 that is port 0.3 pin should be configured as an output pin. So this register will be used to send logic 1 provided if that particular port pin is acting as an output port pin. If you already by using FIO direction register, you have to configure this pin as output, and if you want to send logic 1, the corresponding bit position in FIO set register should be made it 1, and if you made it 0, it doesn't have any effect, and if you made it 1, through that particular pin it send logic 1 to the outside part. Similarly here, the fifth pin of port 0 sending logic 1. Okay, this is about FIO set register. And similarly we have one more register to access the data, that is FIO clear, FIO CLR, that is fast port output clear register. Again, this is a register controls the state of the output pin. So if you write 1 on a corresponding bit position, that means you are sending logic 0 to that through that particular port pin. It is similar to FIO set, where if you use the FIO set, you are going to send logic 1, and if you want to send logic 0, then you have to go for FIO CLR register. So that means again FIO CLR register is of 32-bit wide. If you want to send logic 0 via that particular port pin, again that particular port pin should be configured as output port. So if you write 1 on a bit position of the FIO clear register, that particular through that particular pin you are sending logic 0, and writing 0 on the particular bit position doesn't have any effect. Example, let's consider this is FIO clear register, it is 32-bit size. So here through port 0.3 pin, if I write third bit position as 1, that means via pin number 3 of port 0 I am sending logic 0 value, provided the third pin of port 0 should be output port. Similarly here, let me consider the another port. For example, if I make the 9th bit position of this register as 1, that indicates I am sending logic 0 value via 9th bit of port 0. Again, it is very important, the 9th bit of port 0 should be configured as output port. Okay, this is about FIO clear register. The next register is FIO pin, that is fast port pin value register. This register is 32-bit wide. This register is used for both reading the data from the port and writing the data to the port. If you are reading the data from the port, then the current state of the digital port pin can be read from this register regardless of the pin direction or alternate function selection. And similarly, if write anything onto this register which places the corresponding values in all bits of the particular port pin. Let us consider this FIO pin register. Suppose if you are reading the data of port 0.0 pin, irrespective of the function of port 0.0, whether it may be performing the first default function or first alternate function or second alternate function or third alternate function, the corresponding value of this particular port pin will be stored in this position. That means it will store 1 or 0 irrespective of the function of the pin, irrespective of the direction of the pin. If you are reading the content via FIO PAN register, then the pin value will be stored in a particular bit position. Suppose if you write to this particular bit position, then irrespective of the direction of this particular port pin, that is 0th pin, the value 1 will be derived to the 0th pin. Okay, this is about FIO pin, which can be used for both reading and writing. Clear? So with this, let us try to understand some objectives of this course. The objective of Embedded Controller Lab is to understand the instruction set of ARM Cortex M3. It is a 32-bit microcontroller, and the software tool required for programming in assembly and C language. And the program to program the ARM Cortex M3 using the various instructions in both in assembly language as well as in C language for different applications, and interfacing the external device and IO with ARM Cortex M3. So these are some of the objective of this